Hello, this is week 4, and I wanted to send this little snippet out on multiplying polynomials. The direction here in the examples say to simplify the expression to a polynomial in standard form. And let's go ahead and get started. The method I'm going to use here is called the box method. Of course, we could use another method where we simply distribute x squared across all of these terms here. And once we distribute x squared across all of these terms, then we would go back and we would grab the negative 2x and distribute that across all three terms. And then lastly, we could take, let me change colors here. We would take the negative 3 and distribute the negative 3 across all three terms, performing that operation over and over again until we're finished. And then we would add up all of our results. And the answer is going to be the same as what we're about to get using the box method. But the box method over the years has become the preferred method. It's very visual, it's very straightforward. So let's get into it. Notice that we have x squared minus 2x minus 3. We're multiplying that by 2x squared plus 4x minus 5. And to do the box method, what we do is we count the number of terms that we have in the product. I've got 1, 2, 3 terms. For the first part, I have x squared minus 2x minus 3. And notice that I listed the 3 terms as such. That makes up the left column of the box. And then if you look at the other part of the problem, I've got 2x squared plus 4x minus 5. And that is going to give us this top row here. And since 3 times 3 is 9, 3 terms times 3 terms, that's going to give us 9. That's why we have 9 boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, that gives us our 9 boxes. And at this point, all we do is we just multiply each row and column, and we place the entry in the appropriate box. For example, if we start with the x squared, if I take x squared and multiply by 2x squared, remember when we are multiplying, we add the exponents together. And so x to the power of 2 times x to the power of 2 is x to the power of 4. Of course, there's an understood 1 here in front of the x squared. So 1x squared times 2x squared is going to be 2x to the power of 4. Then if we multiply the x squared times the positive 4x, that is going to give us 4x cubed in this box here. And lastly, we have x squared times negative 5. That will give us negative 5x squared. So that takes care of the first row. Once we finish that part of the box, we just go down and we will take the negative 2x and we will multiply the negative 2x by each of the column headers here. And once we do that, that will give us, let's see, we have negative 2x times 2x squared. That's going to be negative 4x to the power of 3 in this box. Negative 2x times 4x is negative 8x squared. And we have negative 2x times negative 5, which gives us a positive 10x here. Excuse me. So that finishes the first 2 rows. And lastly, we'll grab the negative 3. And we will distribute the negative 3 across each of the terms here on the row header or the column headers here. And negative 3 times positive 2x squared is negative 6x squared. Negative 3 times positive 4x is negative 12x. Negative 12x. And then I have negative 3 times negative 5, which is a positive 15. And once we have done that, the box is completed. And the only thing left to do is simply combine like terms. And I used a color coding scheme here so we could get a visual on the like terms. I only have one x to the power of 4 term. That's 2x to the power of 4. And then if you look at the purple colors here, they represent all of the cubes. And if you add negative 4x cubed plus 4x cubed, that's going to zero out. Hence, we have no cubes in the final answer. And then if you look at the green entries here on the diagonal, if we were to take negative 6x squared minus 8x squared minus 5x squared, That would give us negative 19x squared, which we see here. And then moving along the diagonals, I've got the red here, which represents the linear terms. If we take negative 12x plus 10x, that gives me a negative 2x. And then we have our leftover constant term here, which is 15. And again, this is called the box method. And if you prefer to distribute, you're going to get exactly the same answer. But again, I've noticed that over the years, the box method has become more prevalent. And it's not really a bad way to do these. I hope that helps.